So the question we're looking at today is a spacecraft traveling at velocity of -20, -90, 40 meters per second is observed to be at a location 200, 300, -500 meters relative to an origin located on a nearby asteroid. At a later time, the spacecraft is at location -380, -2310, 660 meters. A. How long did it take the spacecraft to travel between these locations? How far did the spacecraft travel? What is the speed of the spacecraft? And what is the unit vector in the direction of the spacecraft's velocity? So, looking at A here, we know that we're going to need to find the time. And we know that velocity is equal to distance over time. Now, it already gave us the velocity right here, and it gave us the distance. Well, no, we actually have to do some vector subtraction to find the distance. So that is just real quick and easy. You just do the final minus the initial. Our final here is -380, -2310, 660 meters minus -20. Oh, nope, that's the velocity. Minus 200, 300, and -500 meters. So we can do that easily in our head. That is equal to -580, -2610. Whoops. And 1160 meters. So that's the distance, and our velocity is -20, -90, 40 meters per second, which is equal to -580, -2610, 1160 meters. And all we're missing is the scalar here, that is time. And through some division, you can just do this divided by this, and then this divided by this divided by this, and you get the same scalar. Every time it is equal to 29 seconds. So T equals 29 seconds. As you can see, the meters cancel out. So we are in the right format here. Next is, how far did the spacecraft travel? When I'm doing the distance of vectors, which is essentially what this is here, is we already have the distance in vector form, which was -580, -2610, 1160 meters. Of course, it also has a distance, but I mean also the direction. But essentially, what this is it is just a line, because it did go in just the same direction the whole time. So really, I look at this as just the hypotenuse of the distances, whether it's z or x or y. So to find the distance, you just basically do Pythagorean theorem on the components of the vector. This will give you the distance. This is meters. And after formulating all that, plugging that into the calculator, you get 2914.46 meters. That is how far the spacecraft traveled. And C, what is the speed? Okay, so speed is remembered as distance over time. And now we have both of those, we just solved for them. So V equals 2914.46 meters over 29 seconds, which is equal to 100.499 meters per second. So that's how fast it was moving. And next we have to find the unit vector of the direction, with the direction of the spacecraft. So that's noted as the V average, velocities average, over the magnitude of that, the magnitude of the average, which we know that speed already is the magnitude of the average velocity. So you can just, we already solved for this, so you can just plug that in. It was a constant velocity, so we don't have to solve to get the average. So that's just what they gave to us. And then the speed that we just solved for, and that gives us the unit vector negative 0.199 which we know has unit vectors don't have units, as they cancel out as well. So I already made sure that this added up to 1, and it does, so we know that is a unit vector.